We'll be continuing chapter 2 today, talking about functions and graphs. And we're going to look a little more at their graphs and different properties of the functions. Our objectives today are to identify intervals where the function increases, decreases, or is constant, use graphs to locate the maximum and minimum, test for symmetry, and identify even or odd functions and recognize their symmetries. The last two we will do in part 2 of the video. So I have this visual here just to help us realize that we've actually done a lot of increasing and decreasing of functions before, just in real life situations. So it wants to know what are the intervals on which the given function is increasing and decreasing. State the minimum and the maximum. And the interval is going to change when it switches direction. So if you look at where it is decreasing, it looks like it's a pretty steady decrease from here to here. So that would be from year 1955 to year 1970. And sorry, that was for the decreasing. Let me just switch these words around. Decreasing, I did that first. And then we'll make this one the increasing. So increasing is going to be where it starts going up, and it's steadily going up all the way from 1970 in this case. I would probably take either, if you want to say 2014, it's a little dangerous to say infinity on this because we aren't sure. But if you are looking at a graph that's not talking about years, it probably would be safe to say it's going to the positive infinity direction. So I would take either on this one. Okay, the minimum is just the lowest point. So our lowest point here is right here at 1970. That is when it happened. And if you look, it does tell you that specific point was 14.1 miles per gallon. So as a coordinate, we could say this, and we'll look more about how to write the minimum and maximum later on. The maximum is wherever it reaches its highest point. So here in 2014, and it's around 35. If you look over here, it gives you an exact amount of 36.4. So now if we look at this one, I already put the solution on here and I'll explain where these answers come from. So again, we're trying to find where it's increasing, decreasing, or staying constant. And you're going to switch your interval whenever it's changing direction. So we're going to start with an increasing from negative infinity to negative 1. So you see right here, it begins to change directions. And it does that until positive 1. So that's why it says decreasing, because it's going down. And then it switches directions again and starts going up. So that started at 1 and goes all the way till forever because of the arrow. So that's why it's 1 to positive infinity. So you're going to want to list whenever it starts changing direction is going to be a new interval. And on these you're going to be using parentheses because there's overlap. So we'll just be using parentheses on these. And now looking at maxima or minima, I usually say maximum and minimum. It's a little easier. So identify the relative maxima and minima for the graph of f. So the solution of this one is the relative maximum. We usually write it as an x coordinate, so it's where x is negative 1. And you can see that red point here was where the x was -1. And then the blue point is a relative minimum. So that means on the graph, yes, there's some lower points down here, but it does start shifting directions. It does hit a minimum right here at 1 and then ends up going back up. So the word relative is important. This is a relative max in red because that was a maximum point before it switched directions. And the blue point is a relative minimum. That is a lowest point before it switched directions. So you could have multiple relative maximums and relative minimums. Okay, let's look at this one here. It says identify the relative minimum for the graph of f. So our minimum point here is the 3. Let me do a different color. So that's where x equals 3, because that's on the x-axis. And another way we could write this is the relative minimum of f of 3. You could write that it looks like it's about 98.5. It looks like you could trace it back over here. We'll estimate there. And this is tracking someone's temperature, so they had a fever and then it's going down and going up and then remaining constant at a time. So sometimes you see this as f of x. So it's saying what is the x? It's the 3. And at that 3, we're going to get 98.5 degrees for a temperature. Okay, now where is the function decreasing? So if I follow my graph, it's going down from here to here. And you always write your intervals in terms of x. So it goes from 0 to 3 in the down direction, and then it begins to increase from 3 to 5. And then that blue is where it's constant from 5 to 7. And it does have that dot at the end to show it doesn't have an arrow going forever and ever. So we're going to end it at the 7 instead of infinity. And the last one, state the values of x for which f of x is 99.9. This should have been 99.5. Little typo there. Change it to 99.5. So it wants to know what is the x. State the values of x. So x equals, we want to know what is this missing x that's going to give us 99.5. So if I find 99.5 on the graph, we have it here. And you can also estimate it hits 99.5 there as well. So it's when the x is 1. Or when the x is, looks like 4.5. And 4.5. So that means if you look at the label, at 1 hour after 8 a.m. and 4.5 hours after 8 a.m., your fever is at 99.5 degrees. So you're just finding that missing x. What is f of x? The missing x that would give you 99.5. And sometimes you will have more than one like we did on this example. Okay, let's look at some definitions here, and I would definitely recommend printing this PowerPoint off just so that you can have these to study. The function f is an even function if f of negative x equals f of x for all x in the domain of f. So pretty wordy, it'll make more sense when we do some examples. So the main thing is the right side of the equation of an even function does not change if x is replaced with negative x. And the graph of an even function is symmetric with respect to the y-axis. So that means it can be reflected over the y-axis. Symmetry, you can think of reflections, and we'll have some pictures coming up to illustrate this. An odd function, it's odd if f of negative x equals negative f of x, and I think of this as opposite for all x in the domain of f. Every term on the right side of the equation of an odd function changes its sign if x is replaced with negative x. And the graph of an odd function is symmetric with respect to the origin. So to think of that, you would want to be able to draw a diagonal in your graph, and you should be able to reflect your image over that diagonal. So here's some visuals for forms of symmetry. So if it can be reflected over the y-axis, it is an even function. If it's symmetric with respect to the x-axis, that is neither. And you can see this one does not pass the vertical line test. So it is not a function at all. And then letter C, this is symmetric with respect to the origin. So if you thought of a diagonal drawn here, you can see it got reflected over a diagonal, so that makes it an odd function. Okay, and here's a chart that I think will be helpful for you to look back at if you can print it off. So just different definitions of symmetry. So the first one, the graph of the equation is symmetric with respect to the y-axis. If for every point x, y in the graph, the point negative x, y is also on the graph. So if you want to test it, you could substitute negative x in for x, and it should give you an equivalent equation. And this would be an example of an even function. And we just looked at one where it was symmetric with respect to the x-axis, and usually it is not a function if it can be reflected over the x-axis because it wouldn't pass the vertical line test. So in this case, if you were using a formula, if you substitute negative y for y in the equation, you would get something that's equal. So that is neither even or odd. And the last one, if it's symmetric with respect to the origin, where you can draw that diagonal and reflect it over that, you should be able to substitute negative x for x and negative y for y in the equation. It's pretty much turning coordinates into their opposites. That is an odd. So if a coordinate on the graph was 1, 2, when you reflect it over the origin, you're going to get a point -1, -2. So we'll look at some more examples to help us understand this chart better. So here's some ways we can test for symmetry. So this one says determine if the function x equals y squared minus 1 is symmetric with respect to the y-axis. So first we're going to test if it's symmetric to the y-axis. And that would mean that it's an even function. So to see if it's symmetrical to the y-axis, we're going to substitute negative x for x to see if it produces something equivalent to the original. So if I take my original and substitute negative x for the x, does it match the original? Well, to me, that looks like it doesn't match. You could even rearrange this. You could multiply this by -1 to see if you end up getting x equals the same thing. But you would end up with negative y squared plus 1. So this top one and the new one do not equal each other. So the function is not symmetric to the y-axis, so it is not even. Okay, if we look at this one, now we're going to see if it's symmetric with the x-axis. So same equation, but this time x-axis. So for this one, we're going to substitute negative y for y to see if we get an equivalent equation. So let me write the original. Let me replace the y with a negative y. Bring everything else down. So I'm going to get x equals negative y times itself is positive y squared minus 1. So does this match the original? Yes, it does. So yes, equal to original. So this one, the function is symmetric to the x-axis, which doesn't make it odd or even. It's just a fact that it's symmetric to the x-axis. Okay, now to see if it is odd. So to see if it's odd, you're going to substitute negative x for x and negative y for y to see if it produces an equivalent equation to the original. So I'll write the original down. So let me write that so we can keep track since we have to do a couple substitutions on this one. I'm going to substitute negative x for x and negative y for y and see if I get the original equation back. So this is still negative x. Negative y times itself is going to be positive y squared minus 1. So there it doesn't look the same. If I try to multiply by negative 1 to get it to be x equals something, I'm still going to get a negative y squared and then plus 1. So you can see these do not match. So no, not equal. The function is not symmetric to the origin, so it's not odd. Okay, so here's a visual of that one that we were just trying to figure out. So we said it wasn't symmetrical to the y-axis or the origin. And if you graphed it, you'll see why. It's only symmetrical to the x-axis. So if I looked at my line of symmetry, it looks like it's the x-axis. It got flipped over that. It does not pass a vertical line test because I could draw vertical lines everywhere and it's not going to pass. So it is not a function of x, and they show another line here. Two values of y correspond to the same x value in many different locations. So it doesn't pass vertical line test. And this helps you again see why it wasn't symmetrical to the origin or the y-axis as well. Okay, here's another example we're going to look at. So the original equation is right here. So we're going to start by replacing x with negative x. And you end up getting a positive x squared plus y squared equals 25. So this does match the original. So that means it is symmetrical to y. And then a test for the x-axis. We're going to replace y with negative y. So if I do that, I still end up back with a y squared. So it does match the original. They are the same. So it is symmetrical to the x-axis as well. So in a test, if it's symmetrical to the origin, we're going to replace the x with negative x and the y with negative y. So if you do that, when you square both of those, you end up back with the original. So it is also symmetrical to the origin. So for this graph, it is symmetric with the y-axis, x-axis, and the origin. This is a perfectly symmetric graph, which is going to be a circle that we'll look at on the next slide. So here would be the graph of that. X squared plus y squared equals 25 gives you a perfect circle. So that's why it had 3 ways of symmetry. You could draw a diagonal and it would reflect across that through the origin. It reflects over the y-axis and it reflects over the x-axis. Okay, now we're going to end with even and odd function equations. So even functions and their symmetries. The function f is an even function if f of negative x equals f of x. So the graph of the even function is symmetric with the y-axis if it is even. We've already mentioned that. So in other words, we're going to find f of negative x to see if we get f of negative x equals the original f of x. So is it the same as the original or not? And for odd functions, it is odd if f of negative x equals negative f of x. This I think of as the opposite of the original f of x. And that is, an odd is symmetric to the origin. We've mentioned that already. So in other words, we're finding f of negative x to see if we get f of negative x equals negative f of x. So I know that's a lot of letters to look at, but hopefully the examples on the next couple slides will help us understand this better. So let's use equations to help us figure out if it's even or odd. So determine if the function f of x equals x cubed minus 6x is even, odd, or neither. So if it's not even or not odd, then we're just going to write that it's neither. So to see if it is even, again, we've done this before, we're going to substitute negative x in for x to see if it produces an equivalent equation. So in other words, we're trying to find f of negative x to see if we get it to equal the original. We want to know, is it the same as the original or not? If we end up getting f of negative x equals the opposite of the original, then it's going to be odd instead. Okay, so let's go ahead and try this one. I have f of x equals x cubed minus 6x. So we're going to substitute negative x for x to see what happens. So really what we're doing is we're trying to find what is f of negative x. So if I replace the x with a negative x, then cube it, minus 6, replace this one also with a negative x. Let's see what we get. We get f of negative x is equal to, well, a negative x times negative x times negative x. Let me just write it out so you know why we get the answer we get. That's what negative x to the third means. Then I have minus 6 times negative x, so that turns into a positive 6x. So if I simplify that, I have f of negative x equals a negative times a negative times a negative is a negative x to the third plus 6x. Okay, let's see, is that the same as the original? Is this the same as the original? No, it is not. So we know it is not even. Okay, now let's see if it is odd. If it's not odd, then we're going to just have to put neither. So if we end up getting f of negative x equals the opposite of f of x, then it's going to be odd. So we just found what f of negative x was. We said f of negative x is negative x cubed plus 6x. So now we need to find out what is negative f of x, the opposite of the original. Okay, so really what I'm doing is I've taken the opposite of this whole thing. So the opposite of the original is, I'm going to distribute that negative through. Okay, so let's look what just happened. This does match this one. Therefore, this is equal to this. And if we look back here, we said if we get that, it is odd. So this answer is odd. It is an odd function. Okay, let's try two more of these because I know they can be pretty confusing at first. So again, just go back to these steps in your notes, print them off to help you. Instead of f of x, we're going to use g of x on this just to show it could be a different letter than f. So first, let's see if it's even. We're going to try that out. Substitute negative x for x to see if we get an equivalent equation to the original. So here's my original. So I'll write that so I don't lose track. Okay, so now let's substitute negative x for x. Wherever I see an x, I'm going to put a negative x. So I'm going to get g of negative x equals, if I have an even power, it's going to end up turning to a positive. And, sorry, these parentheses should be here. Then I have a negative 2 times negative x squared would be negative x times negative x, which is positive x squared. Okay, so let's see, do these match? This does match this, so it is even. So that means it's going to be symmetrical to the y-axis. So that one's kind of nice because we got that it was even, so we don't even need to try if it's odd because it's not going to be both on this one because it did not end up changing the other function. Okay, last one. Is this one even, odd, or neither? So let me write the original, find if it's even or not. H of x equals x to the 5th plus 1. So I'm going to substitute negative x for x. And I'm going to get, since it's an odd exponent, it's going to stay negative. So did we get that those equal? This does not equal this. H of x does not equal this. So we know it's not even. I'm going to cross that option off. Okay, let's see, is it going to be odd? So the original, okay, again, we want to see, is f of negative x equal to the opposite of the original f of x? So we just found, and in this case we're using h's instead of f's, we just found what h of negative x is. So we already found this first portion. We found that h of negative x is negative x to the 5th plus 1. So we want to know, does that equal this one here? So let's go ahead and try to find what negative h of x is. So again, that means the opposite of the original h of x. So I'm going to take the opposite of my original that I got from up here. So the opposite of h of x is, I'm going to distribute that negative to both of them. Okay, so now let's see. Does my h of negative x equal my opposite of h of x? I'm going to cross that off. This is not the same as this. So h of negative x does not equal negative h of x. So it's also not odd. Therefore, it is neither. Okay, so that's the end of part 1. Part 2 will be a little shorter. And again, please print these off. I hope all these visuals are going to be helpful when you go to do your homework and study.